So,
Yeah, hi, John. Our next speaker today then is John Napiorkowski, who is the chairman of the AI Perl Committee of the Science Perl Committee. His talk today is using Catalyst per context components, and it's a 40-minute talk. Over to you, John.
it probably won't be quite that long, so don't get worried and write out a check to the other. Good day, everybody. I hope everyone's having an awesome time in London. I wish I could be there, but I'm here in Austin where it hasn't rained in months. I guess you're all getting a lot of rain or something. That's what I heard. Anyway, a little change of pace from the heavy duty like rocket science stuff. We're going to talk a little bit about web development, a little palette cleanser. This is a presentation, sort of a work in progress. It's based on a lightning talk that I gave also remotely at the Nevada Pro Conference, and it's on using per context Catalyst components. So then there was a lightning talk, so I just kind of touched kind of a brief overview of what it was all about, and several people reached out to me and asked me for more details. So I'm going to be doing an admin article, and so I'm going to just be showing the code that I'm working on for that admin article. So this is kind of the preview of the admin article, opportunities for you all to like give me some feedback on it, think I'm heading in a good direction, or things are confusing, what's confusing. So let me just step back, and for those of you who weren't there at the lightning talk that I gave, which is probably most of you, if not all of you, what do I mean by per context Catalyst component? So Catalyst, the development framework for Perl, everything is a component. So it's a model view control framework. So models are components, views are components, and controls are components. So each of the three main bits of Catalyst inherit from Catalyst component. And when your components, by default, your components start, when you start up the application, your Catalyst application, it goes in and initializes all the components in the system. And for the most part, all the components are per application. In other words, they're application scope. So what I mean by that is when you're say your application has like 5 controllers, all the controllers get initialized when the application starts, and when we mean by initialized, they get created, they're objects, they're loose objects. An object gets created and saved as registered, and for the entire life cycle of the application, for as long as the application is running, whenever that controller is called, it's the exact same one that was created at the time the application was created. Okay, so that's what a per application component is. That's the default in Catalyst for components. The same thing goes for models and for views. And so, for example, like a lot of people who are using database class with Catalyst, which is a lot of people because that was in the original documentations and everybody just copied that. Your schema gets created once, you get a copy of it, and that same schema is used over and over and over again for every single request that comes in. And the same thing with views. Like for a lot of people who are using, say, the Template Toolkit view, which again, nearly everybody uses because that was the original, like, how to use Catalyst stuff that was written like 20 plus years ago. That view gets initialized once at the very beginning of the application, one object, and that object is then used over and over and over again for every single request. And that's kind of memory efficient and also fast because you pay for all your initialization costs when the application starts up, and it does have a tendency to speed up the request cycle for your clients, okay? Which was a bigger deal in like 2002, 2003 than it is into 2024. But it has a downside. The main downside is that how do you deal with the fact that each request is unique? It has unique data, it has unique request data, and unique query data, right? So in Catalyst, as in many applications, we have this thing called the stash, where sort of like it's a bag of data, and that stash is used to create anything that's used on the per request, on the request basis. From now on, I'm going to say per context basis. Okay. So we hit a login page. We hit the same controller, the same login controller that was created at the beginning of the application. It gets hits the same schema, the same view, and anything that's incoming gets put into the stash. And then, for example, one example might be is you take that stash data, you validate it in some manner. If it's good, it might update the database. If not, you're going to display something using your view so that the view gets called, and your view template will then inspect that stash and display things that you've typed in. So maybe, for example, show the password you typed in and giving a message like it's wrong or something like that. And then this approach works acceptably for applications of a certain level of complexity. But as your applications get more complex, you have like dozens of controllers, hundreds of views, okay, a schema with maybe 300 or 400 tables. You get into this scenario where your using a stash becomes very problematic. Since the stash is not strongly typed, it's very easy to put the wrong data into it. It's very easy to have a typo. And it's also difficult to know what exactly is in the stash at any given time. So for example, when you get to your view, you may not even know. If you have a very complicated initialization, you may not actually know what's in there. You may not actually, a person calling your view from a controller doesn't know what that view needs. Okay? In other words, there's no strong typed interface between each of these components. So one of the things I've been playing with a lot over the past number of years is experimenting with a concept called accept context, which is a feature of all Catalyst components that allow you to initialize the component each and every time it's called. Okay, so let me just review the example of that. So this is, can you see my screen? Is it adequately sized? Just somebody shout out if you can't see what I'm talking about. Okay. Let me turn up.
Can we full screen that?
This is a very classic per application model. Okay. So you have a model, and the model has declares in order to create a application model, we have a component method, and that component method gets called once when the application starts up. And in this case, you can see it's just simply returning whatever date time now is. So in other words, when the application starts, what now is at the moment the application starts gets stored in this model called model time start. And this is a per context model. It looks very, very similar, except instead of having a component method, we have a method called accept context. And the main difference here is that if a model has an accept context method, or any component, when you call it, Catalyst behind the scenes knows, oh, this one's got this model accepts context. So that means I got to call it rather than simply returning the component which had been previously created. So it's exactly the same, okay, except that it's getting to see the context. So that means it has access to the entire request. It can influence the response, all those things. Okay. And it's just simply doing the same thing as before. It's returning the whatever now is at that moment. But the difference when you actually go to use it, and it's just a quick controller. So I'm just creating two methods, two endpoints starting now. One calling the per application model, and the other one calling the per context model. When you go to actually use it, you'll see that there's a difference. When you call, when you hit the endpoint that is calling the application model, it's giving you the same time every single time. And that's the time that the application started. The time when the application initialized that model, which is typically within about a second or two when you start the application. But your per context model is going to give you a different response every single time. So like if you wait a second or 5 seconds and you hit it, it's going to give you that difference. So that's just, in a nutshell, the difference between the two types of components that are available in Catalyst. So now that you know that, what can you do with it? Well, first you should understand a few downsides. The major downside, of course, is that you're creating it every single time, which means that there's going to be additional initialization overhead. I find that with modern equipment, it's not really an issue unless you're trying to be Facebook scale. In which case, if you're trying to build an application that's got to scale to like millions and millions of responses, you're probably writing it in the compiler language anyway. So there's one downside. It's always going to be a little slower because you're building it each time. But because it has access to the context, you can do cool and interesting things. Okay, so I'm going to show 3 different types of per context components. Per context controller, a model called CatalystX RequestModel, and actually it's a different view than the one I'm listing here. My apologies, I've updated it. I'm going to show an example of a view that's a per context view. Okay. So let me first show you the application. Now this is just a standard old school CRUD application, like we probably won't build a gazillion of these. The application is just a task manager, it's a to-do list, and it stores things to do, and it lists them out. So it's a CRUD application, a very simple CRUD application. It's all server side, no fancy single page application. So it's just really straightforward. Just to show you how it works, so that we're all on the same page when we get to the code. You have a form, just using Bootstrap to CSS to make it reasonably nice looking. And of course, there's some basic validations, which I'm using Valiant for. So you'll type certain things in, but in any case, we'll create one. You probably noticed that some of the fields had default values. I'll show you in the code how that's set up. So by default, everything in this application, by default, everything is level 3 priority. The status is always pending, and the due date is always tomorrow. You can obviously go in and change that to whatever you want. Okay. I think we have a lot of validations because that wasn't really the point of this, but with the validation system I'm using behind the scenes, Valiant, you can do all the standard validations where you can say the due date can't be yesterday. You can't, you can set up all sorts of different validations. But I just did some very basic, the value has to be there, just so you can kind of see what's going on. So in any case, I'm creating a task, and you have it, you can edit it. Of course, can't do things like remove stuff that's required. All the basic stuff. Decide it's a higher priority. I know we've all been building, CRUD applications like this, and there are a lot of different ways to do them. The Avid article will go into more detail, probably agonizing detail as to how the whole thing is built, but that's sort of the basic application. So I know you're saying, well, nothing new here. We've all done this, okay? The way I've done this though is using a different approach to the way we initialize components. So let's actually go and look at the source code. Is this, when I switch screens, they did follow? Can you all see my editor? Or
yes,
no?
Yes, we've got your editor.
I just don't know if Google is following my screen. Can we just shout out and let me know?
I think it's fine.
Hi, am I still connected, or did I lose the meeting here?
You can't hear us.
Yeah. Oh, yes. It looks absolutely fine.
Oh, okay, thank you. Okay, so let's start by looking at the controller. Now, this controller is extending a controller that I made specifically for the application. This controller is extending not Catalyst controller. It's extending it's extending. Sorry, let's open the code.
Zoom in.
It's extending Catalyst controller per context, which is on CPAN. And what all this is doing is it takes the base Catalyst controller and it turns it into it basically implements the accept context method, just as I showed you earlier on. Which means is whenever you get this controller, it creates a new instance of it. And that means that suddenly things like attributes become useful. I've consulted on tons and tons of Catalyst applications, and most of them never use attributes because when you're using a per application controller, the attribute gets created when the application is created, and that's what it stays as. You can't actually meaningfully use it in a request. because it's fixed. Now that it's per context, you can actually use the attributes to do things like replace what you usually use the stash for. So like in a standard Catalyst application, you would probably see a lot of routes where you are putting things into the stash and taking them out. You see Catalyst stash all over the place. In this case, I don't have any. I'm not using stash ever. It's not here at all. Because when the application starts, it's getting the task list, which is just well, I'll show you. So it's just basically a result source of the task table using DBase class. So it has the standard fields. Again, for those of you who use DBase class, there's nothing weird here except for maybe the validation stuff, which is coming in from Valiant. All right. So going back to the controller, I'm able to just say, okay, well, we're creating the request comes in, we're creating a new instance of the task controller. This new instance, which is dedicated to this particular request, needs to have a task list, a task result set. I'm not actually, since I set the default model to task, I don't actually have to name it. But you get away with this. If you're actually trying to do this using just like the standard Catalyst controller, you would end up where it would work once the first time somebody viewed the page, and then it would stop working because it would be exhausted. So you get a new task results at every single time. And this allows me to replace the stash. So for the particular page we were looking at here, let's go to this task list. That is hitting, well, first it's hitting root, and then it's hitting this action. It's instantiating a view. We'll go look at the view in a second. Again, this view is initialized each and every time it's called. Okay, so I'm grabbing the tasks and I'm going to pass it to the view. So now what you have is the view is now strongly typed. You have a clear interface between the controller and the view. So there's no longer any guessing about what this view needs in order to work. Unlike where in scenarios where you're using the stash, where you may not necessarily always know everything ahead of time because there's no strong typing. You can have a typo in your stash. You might leave something out, and then the view doesn't work the way you expect it to work. Okay. So this view is strongly typed. It requires a tasks result set. Obviously, you could have it require as many pieces of information as it needs in order to work. This is a demo simple application, so it's only got one. So let's go look at this particular view. Now again, for those of you who use Catalyst, you're like, there's only like, usually you'll have like one view, you call it HTML or something. You'll have it from like the template toolkit view, and it's just one of them. And that view goes and gets templates and does everything behind the scenes. In this case, we're actually going to have a lot of views, just to show you what we're looking at here. And I know that might seem weird to a lot of people who use Catalyst, but in this case, having a lot of views means each view gets to have its own interface and its own display logic. So let's go look at the list view. So the list view is just inheriting from a view that extends a per context view that's on that I created and then put it onto CPAN. It's basically just a very simple embedded Perl type language. Not my favorite type of template, but it's kind of a nice like lowest common denominator. And you can put the template into the data block, or you can put it into a file. For very simple applications, I tend to just toss everything into a data block, just so that I can just load one file, not have to load two files. But if you have a very complicated view, or you're doing views where maybe not everybody working in the view is a programmer, you don't want them to have access to the programming stuff, you can put it into a separate file. So in this case, you can see the view has an attribute called tasks, which is required, which means is if you don't pass it, the application dies. unlike with, like, say, the classic template toolkit view, you may not, you might just get like, weird looking data because it's looking at the stash. So it doesn't die, it doesn't find what it wants. It doesn't die if you had a typo in your stash entry. This application has a very clear, like, this view says I have to have this data in order to work. It's also inheriting from a base view that lays out, like, the base HTML and all that kind of stuff. So it has entire information. And the view is, and again, it's just, you've all seen stuff like this before. It's just embedded Perl. So I'm just going to look over the tasks and just going to output stuff. If any of everybody that's worked on Mason or like Modulicious, this should look pretty straightforward. And if you haven't, if you know Perl, there's probably, you have to spend a couple of minutes looking at it, something you probably get. Okay, so again, this view gets created each and every single time that the view gets called, which means is, again, it has a explicit interface. Over the long run, although you have to create more views for your application, I really believe that this will end up giving you a much more robust application that's easier to maintain, because you're going to be able to look at this view and know exactly what it needs in order to function. Okay, so let's go back now and look at the view that creates the task. Okay, so that's, again, this is what it looks like on the web page. Let's go back to the controller. So the controller is in, what you're getting to is here. That's the end part. It's going to go through, since this is using chaining, it's going to hit the root first, the root action first. There's not a lot going on here. With chaining, when you first build applications, you often have these chains that don't seem to do anything. My approach to using chain is I like to break stuff up, because I always find sooner or later it's needed. Like, this is a place where you'll end up hanging some sort of validation or some sort of logic eventually. So it'll first hit this piece, and then hits the prepare. So what is prepare doing? It's calling a method on the controller called prepare new tasks. So let's go look at that. So that's this method right here. So there's not a lot going on here. When you call this method, all it's doing is it's assigning to this attribute task, which we're allowed to use now because, again, this control is created each and every single time it's hit. So you can use attributes meaningfully now. And it's going to put into the task attribute a new task with some default data. Like as I pointed out, there was middling priority, status depending, and the due date is always today. Is always this moment, today. And it puts it into the task attribute. So again, instead of using the stash, I'm actually using the attribute. Then I'm calling the view, the add view, and I'm passing the task to it. Afterwards, I'm getting here, which is the get to add. Again, there's not a lot going on here. It depends quite often. Again, it's the demo application, so you do often find that separating your get and post actions is useful, because you often need to do, in real life applications, there's always stuff that's a little bit different between the get and the post. But for this demo application, it's very simple. So let's look at this add template. So again, this add template is getting the task attribute. So again, we're defining it. It's required to have the task for these. So if you don't pass it, or if you make a typo, you get a hard error when the application starts. Now this, since the add and the update share the same underlying form, which is pretty common for those of you who do a lot of CRUD applications, I basically broke out the form bits into its own include, so that both the add and the update can use it. So in this case here, it's an include view, this form view, and it's going to pass the task along. So it's the same for the update as well. And you can see it's also passing along. I still like to break them up, because quite often the update might have some additional information or display things differently from the create. For this demo application, it's exactly the same, but once your application becomes real, you'll know that things end up changing over time. So the actual form itself picks up the task. Again, it's required, so you know exactly what this form needs. It's like it says it right here. And because I've created a separate view for it, you can have all this like useful display model information that can be written clearly and cleanly. Labeling information. So again, to look at here, the priority, the status, these labels, we're just preparing them. They're all set up. Since we have access to the context, the view can just simply go to the appropriate label model and get a list of all the labels that it needs. So it makes everything nice and easy. And then going down into the template. This also is using Valiant form builder, which is similar to the Rails form builder, where you are basically just building the components based on the data. So like most of it is pretty straightforward. This is the title. You just pass the class information. The Valiant form builder allows you to theme. So like for the purpose of this demo, I just simply put all the classes over and over again. But if you're building an application, you can actually build a theme of how your controls look. So that way you don't have to continually put it in over and over again. That's a total aside from this, but I just didn't want you to think that you couldn't make this neater. So then, getting down into the checkbox area, just grabbing the checkbox information, it's building everything. Any errors get displayed and so forth. All those kind of things are all put together, and get an application. Let's go back to here. So we were looking at the edit. So like, you can't take stuff out without creating it. So basic code application, but the underlying implementation here is totally different from what you've probably seen for a lot of these kind of applications. The controller is per context, the view is per complex, and I missed it. There's a per context model, which I'll show you right now. One of the things about Catalyst and these kind of applications is when you get the incoming data, it's available on the request as just like a hash, and that can open yourself up to a lot of security issues. It's just a little wishy-washy. So I've created a per context model that takes the request information and maps it to a model. This is an approach, and let's look at the code for that right now. So this is So this is a model that represents what you're expecting the post of the create form to look like. So instead of just simply getting a hash and just trying to update the database directly, it's taking that request data and it's mapping it to these objects. Now, since this is a little more complicated because the task labels is a one-to-many, it's kind of a many-to-many thing, right? So you have to have a breakout. But everything that comes in gets mapped directly to an attribute that's marked as a property. We can follow nested information by specifying an underlying model. This works for many-to-many, one-to-many, all that kind of stuff. So I found this type of approach has been really effective in other frameworks that I've worked on, where the incoming request gets mapped to a struct or an actual class. And then again, this fixes a lot of issues with incoming data being very wishy-washy. Like when you just have a hash, you can easily make a typo. You can easily you can open yourself up to a lot of security issues. So in this case, I'm specifying my request has to look like this, and this is what gets passed to the task for doing the update, right? So I'm passing in an actual model, and the set request method inspects that model to make sure that it's mapping fields that the DBS class is expecting to the field model. And when it doesn't find things that it wants, that's like a hard error. So again, I'm improved the interface by making it a strongly typed interface. I also find that there's sometimes your request stuff, you're always like needing to merge request data. So it's really nice to have just a class for it. I've seen on a lot of Catalyst applications in the wild, and the controls will just be a mess of like bringing in incoming data and somehow trying to whack it into shape. So you have these actions that have like 80 lines of playing with the request, and it's just really messy. So it's nice to be able to just outsource that to a model that knows about the request, because you can just simply isolate it here, and it's reusable. So like if there's if you have other controls that need to use the same request pattern, you can just simply use the same one. Another thing that could be interesting here is a lot of the other frameworks that I've seen that are following this pattern, they use this as a great place to stick annotations for creating open API. And that's something that I would be very interested in adding to this. It would be really great if you could say, like, given a request, giving a particular endpoint requires a particular request body, then being able to say, like, add some annotations to this and build an open API document from it would be really cool. That would be like another step. But currently not there yet, but I think that's a possibility. This CatalystX request model, it supports classic form post. It also supports JSON. So you could use this if you're doing like strictly API work. So that comes in. We set the task, gets set from request. The way Valiant works is when you do the update. I guess I could just look at that so you can see what we're talking about. So this is the set from request method. There's a method. It adds a method to the base class that's called setConst recursively, which is a recursive form of update and create, which is typically super dangerous. Like we always say, don't do that because if you don't, unless you're very very certain of your incoming data, right? But since we're certain of our incoming data, because the incoming data got mapped to an explicit class, we know what it is. So we know that it's safe. So we can go ahead and just simply recursively update. And then called insert update. Just to look at that. So there's some validations that get stuck on the model. If any of these validations fail, what ends up happening is it aborts the insert or update, but leaves the model alone, which you can then call. You get a method called valid. The valid returns true if it's valid and false if it's not. Again, that's slightly off from the. I just wanted you to know how to understand how that works. So, okay, just going back to review, a very standard CRUD application, but we built it using all per request components. I know if you look at this just like as it is, it probably looks very complicated for the demo application. That's always sort of a problem with Catalyst. Catalyst actually sucks with doing demos because you have to do a lot of stuff to use Catalyst. But where it shines is when you're actually doing real life work, where everything is very complicated and you need to have everything neatly organized. So, in using approaches like this on applications that I've consulted on, I find that it just makes the application a lot more robust because all the interfaces are defined. You get hard errors as opposed to like weird errors or just missing data as you get when you're using the stash. And people who onboard to the application are able to figure it out faster because they can, like somebody who's working on, say, this view, like they go to look at it and say, okay, they know that this view needs a task. And that's what it needs to get passed in order for it to work. So it's all very explicit when you go to look at it. When you go to look at a view using, say, like the old template toolkit view, you can spend a lot of time trying to figure out how it needs to work, particularly if it's a complicated view with a lot of inputs. So, all right, well, that's basically it. My intention, basically, I'm through the admin article and taking this, I'm just building upon it. Add a lot more detail. Eventually, this is going to tie back into Science Perl because there's going to be an AI-enabled version of this tool. Hopefully, by sometime next summer, we'll be presenting about that. So, anybody have any questions? Does that make any sense, or are you just being polite?
Thank you, John. Yeah. Are there any questions from the audience?
Yeah, thank you very much, John. Is the example application that we were just looking at, is that something that we can access by GitHub or CPAN?
This application is on GitHub. I will. Well, let me get it right now. I'm going to put the link into the chat channel so that everybody can see it. Where is it? Maybe I didn't push it out. I will. This application will be on GitHub if it's not there, and I'll post it to someplace where you'll find it. Sorry about that. I thought I was. I guess I failed to push it out, but it's intended to be there. And when I write the admin article, there'll be links to it as well.
Very good. Any further questions? Okay. Thank you very much again, John.
Thank you.
Thank you.
Yeah.